Hello everyone. In this video, we are going to explore one of the most important concepts in Java programming called as a JDBC. Also, you can call it as a Java database connectivity. Do you know how the Java applications communicate with the database, like reading or writing the data or alters a table? The answer is JDBC. It's a platform that makes all it possible. Let's see what is JDBC. A JDBC stands for Java Database Connectivity, and it's a standard Java API that allows the Java programs to interact with wide range of database such as like MySQL, Oracle, PostgreSQL, or even the MySQL server also. Actually, the JDBC it acts as a translator. It can speak the languages like the SQL query languages. It can speak with the different database languages. As I mentioned before, like MySQL, it can able to interact with the MySQL, Oracle, Postgres, MySQL server, right? So it can interact with, it can speak the SQL query languages. Why the JDBC is needed? Before JDBC, connecting to the database was tedious and more complex, and moreover, it's a platform dependent. But when it comes to the JDBC, it provides a uniform interface so that the same Java code can work with the different database without changing the driver. In other words, the JDBC gives us a portability, simplicity, and consistency to connect and interact with the databases. Let's move on to the architecture of JDBC. It's mainly consists of two layers. The first one is JDBC API, which provides an interface for developers, and the other one is JDBC driver manager, which loads appropriate driver for the database. Let's understand the JDBC architecture with some real world analogy. Think of it. Imagine you have a universal charger for your electronic devices. The charger itself represents a Java application. Okay, so assume that the charger it's like a Java application. But here the thing is, different countries have a different power sockets and the shapes also, right? So in India, the US and UK, in every country they have their own different plug types. So how do you make your universal charger works in everywhere? The answer is you have to use an adapter, right? That's use a JDBC driver. Now the JDBC API, it's like the set of rules or design the standards that ensures your charger knows how to connect, and it defines how the plug should fit, what the voltage to expect, and how to transfer the power supply, right? And the driver manager, you can think of it like a traveler kit that can automatically pick the right adapter for the country you are in. If you are in India, it picks an Indian plug, and if you are in US, it can pick the American plug. So just like that, the flow like this: your Java application, the charger, use the Java API as a rules, goes through the driver manager as a traveler kit, and finally connects to the database. That's a power source, right? That's how the JDBC connects your Java code to different database without rewriting the code, right? Let's move on to the JDBC driver. So before we begin with the JDBC driver, let's quickly recall that what the JDBC means. As I mentioned before, the JDBC stands for Java Database Connectivity, and it acts as a bridge between the Java application and your database, right? But this bridge, it's not a direct one. It needs a driver to translate the commands from the Java into something the database can understand. So now there are four types of JDBC driver, and each one connects to the database in a slightly different way. Let's go through one by one. The type 1. The type 1 driver, it's also known as a JDBC ODBC bridge driver. Look at here, the JDBC ODBC bridge driver. You can think of it's a double translator. Let's see how it works. The JDBC driver converts a Java calls into the ODBC call. So look at here, the JDBC driver converts the Java language, that is whatever the Java code that that calls converts them. The Java calls converts into the ODBC calls, and then the ODBC driver talks to the database. Okay, it's simple, but there is a catch. This method depends on the ODBC setup and your system, and moreover, it's a platform dependent. Because it goes through the two layers, like a JDBC and as well as the ODBC to the database, and it's slow because of there are, as I mentioned, there are two layers required in order to communicate with the Java application and your JDBC. So it's almost slow. It's very slow, and actually this type 1 was deprecated after Java 8 version. Still it's important historically, because it was the first way the Java applications talk to the databases. And the second one, it's called as a native API driver. This driver converts a JDBC calls directly to the database specific native code. It was usually written in C and C++ languages. It's somehow faster than the type 1 because there is only one layer of translation. So actually in type 1 it has two layers. One is a JDBC and as well as a ODBC layer. But in case of type 2, it has only one layer. So that's why it's a little bit faster than the type 1. However, it still requires a native libraries to be installed on your client machine. So there is a native library that has to be installed on your client machine. So it's not a portable one. So it's also the platform dependent. And the type 3, the network protocol driver. The type 3 is called as a network protocol driver. This one uses a middleware server between the Java application and the actual databases. The JDBC calls go over the network to the middleware, which then communicates with the database and its own native protocol. Actually, this makes it platform independent because it was completely written on Java language, right? And you don't need any native libraries on the client machines. Also, the middleware server can handle multiple types of database. Look at here, the middleware can handle multiple database drivers on its own. The only drawback is it needs the extra middleware layer, which can slightly affect the performance. But overall, it's flexible. Solution used in many enterprise system. Every companies, they have been using it for particularly for the big data. They have been using this kind of drivers. When we have a vast number of data at the time, you can go with this. Okay, and finally the most popular one called as a type 4, also known as a thin driver, or you can call the pure Java driver. This driver, it converts Java JDBC calls into the database native protocol using the pure Java code. No native libraries and no middlewares are required. This is it's faster than all three. It's portable, easy to deploy. So that is that is one of the more advantage of this type 4. And moreover, it's been used in modern database like MySQL, Oracle, and PostgreSQL, and everywhere. So it's been very popular right now, and every drivers which has their own the driver, like every database like MySQL, Oracle, they have their own driver, so it can directly communicate with each other. And finally, the steps, the typical steps involved in JDBC program. Starting with the step 1, load the driver. Load or register the database driver. Actually, in older version, we use this loading the driver manually by using the method called as a class.forName. So what is a class.forName means? It dynamically loads a driver, dynamically loads a class into the application. But in modern JDBC drivers, it doesn't require. Particularly the latest version of Java, it doesn't require this step, like registering, loading, and all these things. Instead of that, instead we are adding the jar files into the Java path. So that is what we have been doing in the modern version. And the second step is to establish the connection using the driver manager, driver manager.get connection. Look at here, driver manager.get connection method, and where you can specify the database URL, username, and password. There are 3 parameters you need to pass. One is the location, or you can specify the path where the database which is located, the database which is located, right? And the second one is like a username and password. And the third step, it's all about creating the statement object using the statement, prepared statement, or the callable statement. And the fourth one is like a executing the execute query, that the statement. So whether it doesn't matter whether it is like a select query or insert query, update or delete query, so you can execute it. Okay. And finally, the processing the results, so which can handles the results, and it returns according to the SQL queries, it returns the results. Either it can be like a result set, or it can returns a number of records which is affected by the query, right? And finally, the last one is like closing the connection. It closes all the connections to avoid the memory leaks. Even nowadays, it doesn't require that, because the JVM, it's an which has an automatic garbage collection. It automatically manages each and everything. Okay. So in the next video, we will be moving on to the demonstrations with all these 6 steps. So let's see how to load the driver, how to establish the connection, how do we create a statement by using the statement, prepared statement, and callable statement, and how do we execute by using the execute query and the execute update methods, and how do we fetch all this result set, and finally the closing connection. Okay. So thank you all, and we'll see you on next video.